Okay, so I want to run over real quick the algorithm, since I'll probably need to rebuild this. But this is the sand dune thing, the essential basic setup from Entagma. But then there's also this area where it starts to build up over objects and stuff like that. So how do we get the sand to kind of build up and start rising specifically that's hitting in those areas? Um, okay, so first off, let's take a look at let me see if I can stop that. Okay, cool. So yeah, so as you can see, the artistic direction probably needs to be worked out a little bit, but yeah, something like that. So it's starting to build up over here. I think he's got a fin over here, which is causing things to build up there. So that could probably be deleted out from under there just to focus on the main part. That's artistic stuff. So anyway, how does this work? I'm going to start with the sphere because I think it's a little easier to kind of visualize. So we've got the volume. We've got the volume VOP. Volume VOP is pretty basic. Settings for that. That's what that's at the moment. Okay, and that goes into the solver. We got a curve with a resample so that we end up with something like, oh, right, because I just have it, I don't have normals, I have it stored in the tangent U. So in that attribute. Okay. Sphere. Polyframe. So we get some basic normals. So just normals, we could have made a normal. And then this little bit of code, essentially what it does at first is we set a up vector and then we get a cross vector which wraps around the cube. And then we do a cross of that and invert it with a negative sign with the normal again, which is pointing out, and then the cross, and then it'll give us these nice wrapping curves that are pointing up and over the object. And so they wrap with the object. Okay, and that did work pretty well with the toy too. So you can see that those are wrapping around and with the object. So stick with the sphere for now. The next thing I do is I've got I just made essentially like a rest for the normals just so that I could store that. And then I just put the normal back to where it was. So now we've got this wrapping vector stored in that position. And then I just reset the normals back to normal. All right. And then here I'm transferring the tangent U, so that curve. If we had the tangent U set to normals, we would see the vectors flowing like this. But we're just transferring that tangent U onto the sphere, so where it's intersecting, essentially in the direction that it's intersecting. From there, we just create a dot product, an inverted dot product of the normalized tangent U and the normals of the circle. And then we just run this expression and say remove point if it's below that. So essentially, like if we change this curve, like if I put a sine wave or something like that on it, this would also update. So we're getting just those polygons that are facing that, and then we're also still getting updating our normals to face to wrap up again. So that's what's going on there. Just making sure I didn't like miss any code, like I didn't scroll enough or something. So yeah, that all looks good. So then we have in geo or in grid, in control curve, and model. Oh, and by the way, this is that set to high field. Okay, cool. Into the solver. So we essentially have the switch that just takes the previous frame only for the first frame, and then we switch it in for 1. And then we just essentially have our end field. So our height field is coming in here. Go ahead and delete that, get that out of the way. Probably that too. Well, we'll just take it off this side. Okay, so that's what's going on there. And then this right here is our direction curve. I don't think we've got any normals on that yet. It's still the tangent u. But then here, this is where our model comes through. And so we've got this point wrangle. It's just making sure that our normals are set, that we've got a rest for that, which I don't know if we need that, but yeah, keep it for now. And then we're just setting our normals back to face like that. And then we're running another attribute transfer. So it's some of those same nodes that was copied before, just so that we have the tangent u. And then these are how these are connected into this. Maybe we could do something like that, so it's a little cleaner. Okay. Then what's happening here? This is the code. Sure, there's that all here. I'll get it all on the screen. There, that's the code. So there's things that you could play with, the distance. So this is all the stuff that came from Entagma. I just repeated some of this stuff where I did this, but use the second input, which is 0, 1, 2, which is the model that's coming in. So getting the position, getting the instead of the tangent u, I'm getting the normal, which is facing out, I believe is how it was like last left off. And then also getting the original normal that wraps up and along the curve, or the model. Getting the position, getting the distance, and doing another fit. And so here's where some of the magic happens. So I'm doing a volume gradient, and this is based off of the height field, so getting a volume gradient. And then here we're doing a dot with the up vector and the gradient. So the same thing that we did to wrap the normals around the object, we're kind of doing the same thing with some of this, because the gradient, the volume gradient normals kind of wrap around, and I found kind of a cool way to visualize some of that, and that's with the height field scatter. You can actually look at the volume gradient, stuff like that. So you could run this code and set the normals on the points to be that volume gradient, and then you'd see it wrapping around and stuff, and you can essentially see kind of like what some of this code is doing on points. But yeah, it's a nice way to visualize it. And then I played with the gradients, but then so I've got a cross or a dot with the gradient and an up vector, and then I've also got a negative cross with this and this. So now we have three gradients that we can use in different ways. Got the original angle, Entagma, and then I did another dot product with the gradient 3 and the gradients. So doing a dot with this direction 2, the direction 2 along this gradient and this gradient with the direction 2. And then down here we've got a height. This was Entagma. And now I've got some statements to kind of pull from each one of these gradients. And so you can kind of play around with these numbers. But I noticed like with one gradient, it was like a little noisy, but it was pushing the stuff up real well. And the other one was just kind of building up. So that was just from trial and error. But yeah, play with these numbers. Boom, boom, boom. The other thing I could show you is what the amplitude is at. Once we had that. And then, yeah, just doing what Entagma did. Had that volume blur, and then an out, and then an out. And then that just gives us, so that's the solver. I'm converting the height field to polygons, and then I'm just merging it back with the object. And so, yeah, you want to make sure that whatever you're plugging in here, maybe we should do like so we have an intermediary that goes there, so that whatever we have plugged into that null is what's coming out of this other side, right? So now the sphere is getting calculated, getting all the normals, and then we can run the simulation like on those. All right, cool. So anyways, that's essentially the setup, and it seems to work pretty good. We get build-ups and stuff like that. So as the sand simulate and kind of blow up, we'll start getting build up stuff like that. But yeah, that's the gist of it, and then you can play with all the artistic side of stuff. So there you go. Yeah. So hopefully that has been helpful.